Hey everyone, Mr. Andrew here. Today we're going to talk about the Bohr model and what are valence electrons. The learning intention for this lesson is to be able to explain the Bohr model of the atom. And the success criteria is I can draw the Bohr model of the atom for any element with an atomic number from 1 to 18, and I can define what valence electrons are and identify them in the Bohr model. So let's give a little bit of backstory. Okay, so we're right now in history, we're right after the nuclear model has been developed. That's the one that you guys are all familiar with the nucleus, protons and neutrons, with electrons revolving around it. Okay, so in the early 1900s, scientists like Max Planck and Albert Einstein did research on the behavior of light. At this point, scientists had already observed that when white light is passed through a prism, specifically made out of glass or plastic, it splits into all the colors of the rainbow. And you can see an example of what I'm talking about right over here. These different colors are called the visible spectrum because it shows that white light is made up of every single color. So basically, all the light that we see, all the different colors of the rainbow, make up what we call the visible spectrum. Okay. And on this spectrum, like beyond what we can see, there's all other kinds of like wave energy. So we're talking like microwaves and radio waves. We're also talking about infrared light or ultraviolet light. You're also talking about like X-rays. Any kind of wave light or wave energy falls somewhere on this like what's called the electromagnetic spectrum. But the energy that we can see, meaning all the different colors, that's what's called the visible spectrum. And it's a very small portion of the entire electromagnetic spectrum. So, following these observations, it was later observed that when elements, when heated up or when electricity is run through them, would glow in various colors. Now, this is the phenomenon that we use when we see like neon lights. All the different colors that we see are because there's different elements that have electricity run through them. Now, however, when this light was passed through a prism, only certain colors would be present, and the colors would be different from element to element. So what they did was they would take like an element that had electricity running through it, it would glow a certain color. They would pass that light through a prism, and what they would find is that color would be made up of very specific colors in the visible spectrum. Okay, and this would be different from element to element. Okay, and they really wanted to know why that is. Specifically, why is that different from element to element? Okay. Now we're going to expand on this a little bit more later on in this particular unit, but a scientist comes along by the name of Niels Bohr, and he sees the work of Planck and Einstein. We're not going to get into what their work was, but feel free to ask me anytime. I'd be happy to explain it to you. But he sees their work, and what he realizes is we need a fundamental change to how the atom is designed. The model of the atom that we know, the nuclear model, just doesn't work anymore. Okay. And the problem with it has to do with the electrons. Let me show you what I mean. Okay. The model that you guys are no doubt used to has kind of like a nucleus in the middle with these like rings around it. Something like, see how good my drawing skills are. Something like that. Okay. And that's all well and good. But the problem is all of the rings where all the electrons are said to exist, they're all the same distance away from the nucleus. And Bohr says this just can't work. Okay. Bohr instead says that the atom has to have specific energy levels. Okay. And these energy levels are the like rings or the shells where electrons exist. Okay. Bohr's model shows that the electrons in the shells are not all located on the same rings that are the same distance away from the nucleus, and instead electrons exist in energy levels that get increasingly further away from the nucleus. So I'm going to kind of move this over a little bit. Okay. So it says Bohr's model of the atom focuses on stability, and this is important. Okay, Bohr's model is completely focused on stability. He stated that electrons in an atom are going to exist wherever they are most stable. Now, he has a suggestion for how do we determine what is the most stable place for electrons to exist. He says the energy levels, those are the rings, okay? Those are these rings over here, okay? So this is one energy level. This is another energy level, okay? Energy levels are areas of empty space which are stable places for electrons to exist. The closer the energy level is to the nucleus, the more stable it is, and the more likely it is to have electrons. So basically, what Bohr says is every atom is going to have electrons, and those electrons are going to exist in the most stable place that they can find. And the most stable place that they can find are whatever energy levels are closest to the nucleus. Okay. These rings, these energy levels exist like increasingly further and further away from the nucleus. You know, there's another ring out here, and another ring out here, just like the planets. Okay. Just like the planets have orbits that get further and further from the sun, there's energy levels that are further and further from the nucleus. Okay. Bohr's model states that because electrons are all negatively charged, each energy level can only hold a certain number of electrons before it gets full. When an energy level is full, it is more stable for electrons to occupy the next furthest energy level, since there will be less repulsion between electrons. Now, repulsion is not a common word, but repulsion is when two forces push each other away. Like when you try and put two ends of the it's kind of like when you try and put like both negative ends or both positive ends of two different magnets together, they push each other away. That's called repulsion. Okay. So repulsion is basically just any kind of force that pushes two objects away from each other. So Bohr says that electrons are going to try and fill up energy levels that are as close to the nucleus as they can find. But each energy level can only hold a certain number of electrons. Because all the electrons are negatively charged, they're constantly trying to push each other away. And so at a certain point, if an electron tries to get added to a lower energy level, they're too close to each other, and the repulsion between the electrons that are already there and the one you're trying to add is too big. So because of that, the electron gets pushed to the next further level. Okay. So there's rules as far as how many electrons can fit in each energy level. Okay. So as I said before, each energy level can only hold a certain number of electrons before it gets full. The number of electrons that each shell can hold can be found in the image to the right. So in this image, this kind of goes over how many electrons can fit in each energy level. So this red dot right here is our nucleus. Okay. The first energy level, this first ring right here, it can hold 2 electrons. And that's because it's the smallest ring. It's the one that's closest to the center. Okay. So because it's so small, it can only hold 2 electrons. If we tried to add a third one there, they would be too close together and it wouldn't be stable. So after the first one gets full, we go to the second energy level or the second shell. And the second energy level can hold 8 electrons. It's further away, so the electrons can be further apart. And so it can hold up to 8 electrons before it gets full. Okay. But when that one gets full, then we have to move out to the next lowest energy level, which is the third shell. And the third shell can hold 18 electrons. Now, if we go back really quickly to our success criteria, it says right here, I can draw the Bohr model of the atom for any element with an atomic number 1 to 18. So we're only going up to atomic number 18. So atomic number 18 would have 18 electrons. Now, as I mentioned, and you're going to see this again in a minute, but electrons fill up the lowest energy level first, meaning the one that's closest to the nucleus. So if the first shell can hold 2, and the second shell can hold 8, 2 plus 8, that's 10 electrons total. We're only going up to 18, which means the furthest you're going to go is 8 electrons in the third shell. Okay. And there's a reason for that, because once you get past that number, the rules start to get a little funny. So we're not going to dig into that yet. Okay. So the goal is to be able to do any Bohr model that goes up to 8 electrons in the third shell. Okay. Now, before we start looking at Bohr models, there's one more thing I want to talk about, and that's the concept of valence electrons. Okay. Valence electrons are the electrons which occupy an atom's outermost orbital or outermost energy level. Valence electrons are the electrons responsible for an atom being able to form bonds as a result of a chemical reaction and have a massive impact on the properties of that atom. Now, this bullet point, we're going to talk about more in a future unit. But for now, what I want you guys to know is valence electrons are the outermost electrons in an atom. Okay? Okay, so let's look at some Bohr models. Okay? So I'm going to draw some simple Bohr models for you. Okay? And from this, we're going to identify what the model looks like for each of these atoms and also how many valence electrons these atoms are going to have. Okay, this will be good for you to see kind of conceptually. Okay, so we're going to start out with the simplest one. Okay, hydrogen. Hydrogen on the periodic table has the symbol H. Its atomic number 1. And its mass number is also 1. Now, for the mass number for this, we're just going to use whatever mass is on the periodic table, and we're just going to round it to the nearest whole number. Okay, that's just going to be the easiest way to go about this. For the purposes of this exercise, we're not focused on isotopes here. Okay, so we're just going to assume mass number and atomic mass are the same. Okay, so if this is atomic number 1, it's going to have 1 proton. Okay, we write proton like this. It's a lowercase p with a plus in the top right corner. Okay. Now, it's also got 0 neutrons. We write neutrons like this with a lowercase n with a 0 in the top right corner. Okay? So it's got 1 proton and 0 neutrons. And we know that from the mass number. Remember, you find the neutrons by taking the mass number and you subtract the atomic number. 1 minus 1 is 0. Okay. Now I've got to add electrons. Remember, we're still only talking about neutral elements. So if it's got an atomic number of 1, meaning it's got 1 proton, it also must have 1 electron. So I'm going to put my 1 electron on the lowest available energy level. Okay. So the lowest energy level is this first ring right here. So I'm just going to put 1 dot right here. Okay. I'm just going to represent my electrons with a dot. Now, this is my completed Bohr model for hydrogen. And how many valence electrons do I have? I find the outermost ring with an electron on it. That's this one. Okay. And I just count how many electrons are on that ring. So this is my outermost ring, and I've got 1 electron. So I have 1 valence electron. Okay. Let's go to the next one, boron. So boron is symbol B. It's got atomic number of 5. And its mass on the periodic table is 10.81. So we're going to round that to 11. Okay. All right, let's fill out the nucleus. So our atomic number is 5. So I've got 5 protons. 11 minus 5 is 6. So I've got 6 neutrons. And because I have 5 protons, I have to have 5 electrons. So if I go back to my rules right here to how many can fit, remember my first shell can only hold 2 electrons. So I've got 5 electrons total, so I'm going to put 2 in my first shell. And I'm going to put them on opposite sides of each other. Okay, so my first shell has 2 now. It's now full. It can only hold 2. So my next energy level is going to take up whatever is left. My second energy level can hold 8. Okay, but remember, I only have 5 electrons and I've used 2, so I've only got 3 left. So I'm going to put 3 electrons on my next ring out. Okay, I'll put one right there. I'll put one right there. I'll put one right there. Okay. Now remember, valence electrons are the outermost electrons. So I find my outermost ring with electrons on it. That's this one right here. Okay. And it's got 1, 2, 3 electrons on there. So I have 3 valence electrons. Okay. Next one, oxygen. Oxygen is symbol O. Its atomic number is 8, and its mass number is 16. So atomic number 8, that means there's 8 protons. 16 minus 8, that's 8 neutrons. And my electrons have to match my number of protons. So my first energy level can hold 2, and I've got 8. Okay, So I've used up 2 electrons. My first energy level is full. I've got 6 left. My second energy level can hold 8. So I'm just going to start adding them. 1, 2, 3, 4, 5, 6. Okay. So I've put 6 electrons in there. So now I have 3, 4, 5, 6, 7, 8 electrons total. My model is done. Now I'm going to look at my outermost ring that has electrons on it. That's this one. There's 1, 2, 3, 4, 5, 6 electrons. So I have 6 valence electrons. Last one, chlorine. Chlorine is symbol Cl. The atomic number is 17, and its mass number is 35. So I've got 17 protons. 35 minus 17 is 18 neutrons. And I've got 17 electrons. So I'm just going to bookkeep them right here. I'm going to keep a tally. Okay. My first energy level can hold 2. So let's put 2 right there. Yeah. Make it a little smaller so it can fit better. It's 1, 2. Okay. My first energy level has 2 electrons. So I'm going to subtract 2. I've got 15 left. My second energy level can hold 8. So it's not going to be able to hold them all. So I'm just going to put 8 on there. Okay. Subtract 8. I've got 7 left. So then my next energy level out is going to get 7. 1, 2, 3, 4, 5, 6, 7. Okay. Minus 7. We're at 0. Okay. So my outermost energy level had 2, 4, 6, 7 electrons on it. So I have 7 valence electrons. Okay. So this is kind of the important thing to notice is that at a certain point, you can have more electrons total, but have fewer valence electrons. They won't all be valence electrons. Okay. All these electrons that aren't in the outermost energy levels, those are called core electrons. Okay. And those don't play as big of a role as we'll see later on compared to valence electrons. Okay. So remember, valence electrons, you find the outermost ring that has electrons on it, and then you just count how many electrons are on that ring. Okay. So with that, we're going to stop here. If you have any questions, feel free to come see me, and I will see you next time.